Okay, everybody, so what I'm going to try and do right now is go through finding zeros of a polynomial without a calculator. So I've got this function right here. We'll call it f of x equals this, and I'm trying to find out where it might cross the x-axis. So the first thing that I have to do is I have to look at all the factors of this number right here, the negative 6. So that gives me 1, 2, 3, and 6. And all the factors of this number right here, this 2, and those have to go in the denominator spot. So it's any combination of the factors of the constant in the numerator and the factors of the leading coefficient that goes in the denominator, which gives me 1/2, 3/2, and then 1, 2, 3, and 6. I don't need to worry about 6/2 because 6/2 is 3. And I don't have to worry about 2/2 because 2/2 is, of course, 1. So these are all my possibilities. So I have those, and I have the negatives of all of these too. -1, -2, -3, -6. So I have 12 different possible rational zeros for this expression. And I'm going to use something called synthetic division to be able to check those. So the first one I'm going to go ahead and check is I'm going to go ahead and check +2. So what I do is I write down the coefficients of each one of these terms in decreasing degrees, and I do a little synthetic division. Synthetic division is the process where I pull the first term down. Again, this is the 2 from here, the 3 from there, the -5, and the -6. Pull the first term down, always just drop it. Whatever's in my little box over here, which is 2, so I'm checking to see if this 2 works. I do this number times this number, and I write it right here. And then I add these two together, that gives me 7. 2 times 7 is 14. And I add these two together, that gives me 9. And 2 times 9 is 18. And I add these together and get me 12. Unfortunately, unless this thing has a remainder of 0 right here, I know that this thing doesn't work. However, we have two different things that would help us minimize stuff or eliminate some things. One of them is called an upper bound check. And if all these numbers are non-negative numbers, that means that 2 is an upper bound, which from my perspective, I just learned that 2 didn't work because it didn't have a remainder of 0. But I also know, because these are all non-negative again, that 3 doesn't work and 6 doesn't work. So I've now eliminated 3 things from that. Okay, so again, that was called an upper bound check. Okay? So the next thing I do is I'm going to go ahead and check, say, -3. So -3, I repeat it again with the original numbers, 2, 3, -5, and -6. And drop the first number down. 2 times -3 is -6. And I add these and I get -3. That gives me 9. That gives me 4. And that gives me -12. And that gives me -18. And I go, crud. It's not a remainder of 0, just like that one wasn't a remainder of 0. However, I can check this, and I can see that this number is not negative, this number is not positive, this number is not negative, and this number is not positive. So that's the check for something called a lower bound. And a lower bound means that there's nothing below -3 if they alternate between non-negative and non-positive numbers, or non-positive, non-negative numbers, whichever way you want to say it. So not only can I cross off -3, but I can also cross off -6. One more time. If these alternate between non-negative and non-positive all the way through, or between non-positive and non-negative all the way through, that means it's a lower bound. Okay, so let's find one that I actually hopefully will work. So I'm going to go ahead and try -1. So when I check -1, I again copy down all of these things, 2, 3, -5, and -6. Bring the first one down. -1 times 2 is -2. 1, -1, -6. 6, remainder of 0. I'm like, yay! -1 is a 0, which means that x plus 1 is a factor. I also know now that I have a new polynomial here, and that's technically 2x squared plus x minus 6, that I went from this big cubic up here. Once I found one that worked through division, I know that after my remainder is here, this is my constant, this is my linear, and this is my quadratic, so that I can write this. I'm going to go ahead and try and factor that. So 2x and x. Factors of 6 are, of course, 3 and 2. And if I put the 3 here and the 2 here, and I make that a plus and that a minus, you can see that I get 2x times x, which is 2x squared. Outside is 4x, inside is negative 3x, which adds up to 1x. And negative 3 times positive 2 is negative 6. So that works, which means 2x minus 3 is a factor, and 3 halves is a 0. And x plus 2 is a factor, and negative 2 is a 0. Okay? Now, just to be clear on this, if I didn't see that this factored, and I couldn't factor it, then I would have to go to quadratic formula or completing the square with whatever was here. However, because it factored, that also means that I could go back to the original ones, 2, 1, negative 6, and I could check some more of these possible rational ones that are up here. Again, I just found that negative 1 worked. I'm going to circle that right now. Like, yeah, that's awesome. And then I'm going to try another one. Now I knew from factoring that negative 2 worked, so let's go ahead and throw in negative 2 here and see what happens. It should work because it factored for the solution. So I bring the 2 down. Negative 2 times 2 is negative 4. 1 and negative 4 is negative 3. Negative 2 times negative 3 is positive 6. I get a remainder of 0. And just like we said, it should have worked. And surprise, surprise, look what's left. 2x minus 3, which is the same factor that I got from up above. So again, this was an example of finding the zeros of a polynomial without your calculator. You know that if they're rational, the possibilities are only from the factors of this and the factors of this, written out like this. Not only do I only have 12 of them to check, but once I find one of them, like here, I know that I'm now down to a smaller thing, in this case from a cubic to a quadratic. The other thing that I know is when I check negative 3, or sorry, when I checked 2, and all of these were non-negative, I knew that's an upper bound and I can get rid of numbers that were bigger than that. Lower bound checks are slightly different. Lower bound checks means they have to alternate between non-positive and non-negative, or non-negative and non-positive numbers. And if they do that, that means that that's a lower bound and there's nothing smaller than it. So hopefully this was beneficial to you. Do also know that if when you get to here again and you get a quadratic, let's just pretend. So we're going to make this up. So make it up. Well, let's say that I had a problem in the very beginning. It was like a 2x to the 5th plus blah, 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 and a whole bunch of stuff. And I'd already found that negative 3 and that 2 and that 1 were all zeros of that problem. And I was left with this for my last bit of synthetic division. A 1, and then a 4, and then a 10. Well, that means that that equation was x squared plus 4x plus 10. And factors of 10 are 1 and 10 and 2 and 5, and none of those get me a 4. So it's this point in time that I have to, again, go to quadratic formula or completing the square. If it was that, I would do x squared plus 4x equals negative 10. Half of 4 is 2, put them in a little square box. Square root 2 is 4, so I put plus 4 here and plus 4 here. This gives me x plus 2 quantity squared. Oops, sorry. X plus 2 quantity squared like that equals negative 6. Square root it, and I get x plus 2 equals plus or minus I root 6 because I have imaginary numbers. I move the 2 over and I get negative 2 plus I root 6 and negative 2 minus I root 6. And it turns out my zeros of this one that I just made up off the top of my head are negative 3, 2, 1, and then these two imaginary ones right down here. Okay, hopefully this was beneficial for you. Again, one more time. If you get down to something like this and it is not factorable, then you know quadratic formula completing the square, and it could either get you imaginary ones like this, or it could get you irrational ones with square roots of positive numbers like the square root of 13. Hopefully this was helpful. Good luck.